Hello students, you are welcome back to Larbi Premium Consult. In today's video, we are going to continue with our topic on logarithm. We discussed the part 1, and in the description section of this video you can check and then watch so that you can build an understanding from there too. So this is actually the part 2 or lesson 2 of logarithm, and in this video we are going to look at the laws of logarithm and its application in that case. So if you are new, kindly make sure to like this video, okay, and subscribe so that you can stay connected. At any time we release any new video, you will be the first person to get it right away. So without wasting my time, let's zoom straight away to lesson 2 or part 2 of logarithm. We are going to look at laws of logarithm. Laws of logarithm. Laws of logarithm. Actually, here we are discussing it from the perspective of core mathematics. So we are there for the perspective of core mathematics. We are not going to dive deeper to the other laws. So we are going just to stick out to what we need to know when it comes to core mathematics. I believe that is clear. So let's zoom straight away into that. So laws of logarithm. Laws of logarithm. We said earlier on that, so if you are in, let me do some recap so that you get to understand. We said earlier on that logarithm of a number refers to the index or the power to which the base must be raised in order for us to get the number. So for example, I have log of, say, 32. Okay, let's say to the base of what? Log 32 to the base of 2. I can say that for me to get this 32, it's going to be 2 raised to a certain what? Number. And that is going to give me what? 32. So in sum or in general, if I have log of b to the base of a, that should give me what? C. And for me to get a b, is going to be what? A to the power of what? C. So that's the whole approach when it comes to logarithm. So logarithm and indices actually are related. So if you understand the concept of indices, then here it becomes so simple for us to move in that case. So that's what we discussed in the part 1. But then you can check the detailed explanations and the examples that we solved. They are in the description section of this video. The link are there. Just go through and then check after watching so that you can also get to understand that concept. So let's continue with the laws of logarithm. So make sure to like this video so that we can get more engagement on this video. So let's see. So actually we have, in this video, we're going to just look at the 3 laws of what? Logarithm. The 3 laws of logarithm, which consists of the multiplication, the division, and then the exponential. So that's how we group the laws of logarithm. We have the multiplication law, we have the division law, the quotient law, then we have the what we call the exponential law. So let's go through. So the first law, let me tell you that's what. The first law is saying that if I have log of let's say x to the base of a plus log of y to the base of a, the law is saying that if I have 2 logs, assuming you have just 2 logarithm what? Terms, okay, the law is saying that if I'm to addition, the law is saying that so far as they have equal base, I should multiply what? The number and attach the log and the base to it. So this is the whole idea. So it becomes what? Log to the base of a, okay, and I'll multiply what? The x and what? Y. So it becomes what? Log x multiplying what? X multiplying what? Y to the base of what? A. So this is why I call this the multiplication law. So here, addition will result in what? Multiplication. That's the law of the first law of what? Logarithm. So if I have logarithm of x to the base of a, logarithm of y to the same base of a, we are saying that the result is going to be the multiplication of what? The 2 numbers from respective logarithm and their base. And then going to be written as this. So that is the first law. So for example, I have log 2, log 3 to the base of 2, plus, let's say, log 4 to the base of 2. I can say that the final answer is going to be log 2, and I'll multiply 3 and what? 4. So it becomes what? 3 multiplied by 4. And I'm going to get what? Log 12 to the base of what? 2. So that's the whole concept when it comes to what? Logarithm, and the first law that we need to understand. So that's the first law that we need to know. I hope you have gotten it. So if you have gotten it, make sure to like this video so that we can reach that target. Alright, so the second law, let's start the second law. The second law. So the second law is actually the opposite of what? The first law. Realize that the first law we're dealing with what? Addition, and that was resulting into what? Multiplication. Is that okay? So the second law, once we are saying that opposite is going to what? Negative. That's subtraction. We are going to subtract what? Or find a difference between two logarithms of the same what? Base. And that's going to result in what we call the division what? Approach. So here, if I have log, actually the full logarithm here can be written as what? Log. I should have first of all told you in the first part of the video, but then it is not something that we need to actually bother our minds on. We've written it in short form as what? LOG, that's log, to represent what? Logarithm. So let's take note of that. So if I have log of a, so log of x to the base of a minus log of y to the base of a, we are saying that this will result in a division. So here, all I will need to do is to repeat my what? Log with the base of what? A. And I will just divide what? The first log, which is the x, in terms of the number, I will divide the number x by what? The y. Is that okay? Yeah, we will just multiply. So because it's negative or subtraction, we will divide the first number by the second what? Number. So it's going to be what? X divided by what? Y. So that is the second law of logarithm. So let's see an example. Let's say example 2 here for second law. If I have log of 2, or let's say if I have log of, let's say 3, log of 9 to the base of 3 minus log of, let's say 3 to the base of 3 is going to give me what? Log of, with the base of 3, then I will divide the 9 by what? 3. So it becomes what? 9 divided by what? 3. So at the end of the day, when you manipulate the results, when you manipulate this whole term, the answer you're going to get is going to give you, is going to be the answer in that case. That's what we are trying to. But here we are trying just to explain the laws in this. So that's the second law of logarithm. Actually, I tell you as the division law or the quotient law. Actually, we are trying to divide what? Two logarithms. So anytime we are into subtraction of what? Two logarithm terms, it results in what? A division. Okay? Just repeat the same base with a log and then divide the first term or the first number of the log by the second what? Number of the same log with the same what? So that is actually the second law with an example. So let's look at the third law of logarithm. That will going to be the last law for logarithm for this video. For the purpose of this video, going to the last law. So let's look at the third law of logarithm. So the third law of logarithm is saying that if I have, or let's say if I have log of a, log of x, sorry, I keep on repeating the base as the number. Forgive me, okay? Log of x to the base of a raised to the power as n. The third law is saying that you can rewrite this in the form n log of a log of x, sorry, to the base of what? A. Stay here carefully. If I have log of x exponent n to the base of a, the third law is saying that I can rewrite this in a form where the exponent will come and multiply the log at the backside, right? So it's going to be n log x to the base of what? A. So let's clarify this law. So if I have log 4, log 2, sorry, to the base of 4, forgive me, log 2 to the base of 4, let's say to the power of, let's say, 4. The third law is saying that here it becomes what? 4 log 2 to the base of what? 4. And at the end of the day, when you simplify it further, your answer should be the case. So that's the third law of what? Logarithm. That's the third law of logarithm. So if I have, let's say, log of, let's say, p, log of q rather, to the base of p, okay, or let's say log of q to the power of, let's say, x to the base of what? P. I can write this as what? X log q to the base of what? P. So that is the general rule when it comes to the third law of what? Logarithm. I hope that is. So we are going to look at the applications of the laws that we just discussed. So this example 1. Given that log 2 to the base of 10 is equal to 0.3010 and log 3 to the base of 10 is equal to 0.4770. We are asked to find, without using tables, the values of 0.4 to the base of 10 and log 5 to the base of 10. So how do you deal with this? So let's see. So with this, it is an application form, okay? So you must first of all write this log of 0.4 to the base of 10. So I can write this as log 10. Remember, 0.4 is what? 4 out of what? 10. So I can say that 4 out of 10. And once you are seeing 4 out of 10 here, which law should guide you to exploit this? That's the division of the second law. So the second law is saying that if I have a logarithm, a division form can result in what? Subtraction. So here it becomes, let me bring it down, it becomes log 10, log 4 to the base of 10, minus log 10 to the base of what? 10. Alright, so once you're able to get this, then you are on the road to go. So let's see. So now I have log 4 to the base of 10, I have log 10 to the base of 10. If you remember the properties of logarithm we discussed, we said if I have log of a to the base of a, it's going to give me what? 1. So likewise, so here, I have log of 10 to the base of 10, it's going to give me what? 1. It's going to give me 1. Alright, so let's see. But I need to break this one down because I have 2 here. So here, which law will help us to break this over to guess what? These 2. It is actually the third law, which is what? Log of 10. Remember, this for I can rewrite an exponent form, so it becomes what? 2 to the power of what? 2. Okay? And here, we are saying that it's going to result in what? 1. So here I can say that, or let me repeat again so that you're okay with it. So it becomes log 10 to the base of 10. So here it becomes what? 2 log 2 to the base of 10 minus log 10 to the base of 10. Remember here we're using the third law. The third law is the power law. So the 2 come and multiply with the log. Is that okay? So here it becomes, remember I have log 2 to the base of 10 as what? 0.3010. So here it becomes what? To get this substitution, okay? So it becomes 2 into bracket 0.3010. Is that okay? Minus, I know log of 10 to the base of 10 is going to give me what? 1. Here. So when you take a calculator, let's punch this and let's see what you're going to get at the end of the day. So realize that here, if I should key in this, let's see, I'm going to get what? Here it's going to give me 0. Here it's going to give me 6, 0, 2, then 0. I think that's what we're going to get. Let's see. Try and let's see. Which calculator, let's see. And it'll give me what? Minus what? 1. So once you get to this stage, okay, here we're having 0.6020 minus what? 1. Well, we said log of 10 to the base is going to give me what? 1. And it's what? Negative what? 1. But in logarithm, if you are subtracting what? Negative number from a positive number, which is less than 1, we don't subtract it straight away. Okay, we don't subtract each other. But if we were to be opposite side where the one was positive and here was negative, we should have subtract. Okay, so this is how you're going to write it. Instead of even subtracting the negative one, you don't subtract, but you're going to place the negative on top of for the one. So it becomes what? 1 bar. So this is how you're going to write it. It's going to be 1 bar plus 0.601, sorry, 0.602 or 0. When you get to logarithm tables, you understand why I've written here 1 bar plus 0.6010 with respect to this. Here you don't subtract, okay? You don't subtract. You just what? Place the negative on top of the one, so it becomes what? 1 bar. Then you add the positive part, or which is the decimal part of the whole to that negative. So here it becomes 1 bar 0.6020. So that is going to be your answer for log of 0.4 to the base of what? 10. To the base of 10. So let's move on to the II part of this. We are giving log 5 to the base of 10. So here, let me write here. So log of 5 to the base of 10. So the idea is that you want to break the 5 down, okay? Or you want to have 2 values, okay? That which one divided, you're going to get what? 5. 2 values, okay? Which one divided, you're going to get what? 5. And why do you think going to be the values in this case? So here it's going to be log to the base of 10 is going to be 10 divided by what? 2. Remember, when I divide 10 by 2, I'm going to get what? 5. So that's how come when you divide, you're going to get 5. So it becomes log of 5. They're going to be the same. So here, remember, this is the same thing as what? This. I hope that is clear. Right. So once you're able to get that, then remember, if I'm having 10 out of 10, log of 10 out of 2, sorry, to the base of 10, which law should come in mind? The second law, right? So the second law is saying that if I have what? Logarithm of division, it should result in what? Subtraction. Is that okay? So here is going to be log of 10 to the base of 10 minus log of 2 to the base of what? 10. I believe that is okay on your side. Right. Realize that if I have logarithm of what? A number having the same base, we said it should be equal to what? 1. If you remember the properties that we discussed, we said if I have log of a to the base of a, it should give me what? 1. So likewise, it's so here, if I have log of 10 to the base of 10, it should give me what? 1. So here is going to be 1 minus, but I know log of 2 to the base of 10 is what? 0.301 what? 0. So it's going to give me 0.3010. I believe that is clear. But here, because we are having the negative values lesser than 1, we can show that we subtract. But if we were to be negative 1 and here was a positive, 0.3010 was a positive, then we should have written it in this form as the first one. So here you're going to subtract straight away. So let's see. So it's going to go 0. Remember, here is 1, so let's go to class 1. So I have what? How many? 4 decimals. So it's going to be 0.3010. 3010. So 0 is going to give me 0. Here I'll borrow 1, making here 10. So meaning that here is 0. Here is what? Here was 10, but I borrow making here 10, and here is left with 9. Here is left with 9 because I borrow 1 from making it what? Here as 10. So I subtract 1 from 10, I'm going to get what? 9. And here is left with what? 9. Okay. And here we are left with 9. Remember, when I subtract 3 from 9, I'm going to get what? 6. And here is 0, so 0. I believe that's okay. So he's going to give you 0.6990. So here, without going through this class 1 Waec with your calculator, just subtract from here. But the emphasis here I'm trying to make you understand here is that if it was to be -1, and here was the 0.3010 was for positive, then you should have write in this form where we are having just have the negative bar on top of the 1, then add the 0 power, the positive power to it, so that it becomes this. But since was the number which is 0.30 was less than 1, we are subtracting from +1, so that we subtract and get your final answer in this case. So this is where we bring an end to the lesson 2 or part 2 of logarithm. So if this video was helpful to you, please make sure to like this video and subscribe, so that anytime we release any new video, you'll be the first person to receive. So I'll see you in the next video where we discuss the equations of logarithm and conclusion. So bye bye.